Let us continue hydrogen and its compounds. In the hydrogen and its compounds, we will take hydrogen peroxide. Hydrogen peroxide acted as oxidizing agent and a reducing agent. That power we will discuss in respective mediums. Now, first we will take a hydrogen peroxide act as oxidizing agent. Hydrogen peroxide acting as oxidizing agent means itself undergoes reduction. So, this -1 oxidation number should become -2. -2 in the sense of water. This -1 oxidation number should become -2, therefore water. Now we will balance this one. Here oxygen is 2, therefore here we will write 2 water molecules. Hydrogen is 4, here 2 is there, remaining 2 hydrogens, acidic medium, therefore H plus. This we will consider acidic medium. Then we will balance electrons, here +2 is there, therefore 2 electrons. For this E naught, for this E naught is 1.77 volt. 1.77 volt. For this potential is 1.77 volt, we can say. Next, we will see in basic medium, we will see. Now we will take hydrogen peroxide. It is undergoing reduction. It is undergoing reduction because oxidizing agent. So this -1 oxidation number should become -2. Okay. This -1 oxidation number should become -2. Therefore, water. Here oxygen is 2. Therefore, 2 water molecules. Then we have to balance hydrogen. Here 4 hydrogens, but here 2 hydrogens. So here deficient of 2 hydrogens. How many hydrogens deficient? That many water molecules you write it. That many OH minus ions you write it this side. Then cancel these water molecules. So we can write hydrogen peroxide gives 2 times OH minus. Now you see oxygen 2, here also oxygen 2, hydrogen is 2, hydrogen is 2. Here -2 is there, therefore write 2 electrons here. This is what medium means, basic medium. It is basic medium, it is acidic medium. Acidic medium. Here E naught. Here E naught is a basic medium. E naught is how much means 0.87 volt. 0.87 volt. Okay. So we said regarding this oxidizing agent, hydrogen peroxide is acting as oxidizing agent. Regarding that we said. Next we have to say hydrogen peroxide acting as a reducing agent, that we have to take. Reductant we have to take. In the reductant in the sense, this -1 oxidation number should become 0. That means it should undergo oxidation. So -1 oxidation number should become 0 in the sense oxygen molecule. Here oxidation number is 0. Here -1 oxidation number, now it is 0 oxidation number. Therefore, it is undergoing what in the sense oxidation. Then hydrogens, let us balance. Here 2 hydrogens, therefore we will write 2H plus by considering acidic medium. Acidic medium. Then +2 is there, therefore 2 electrons. 2 electrons, if you write -2, it is +2, net charge becomes 0. For this E naught is a -0.67 volt. -0.67 volt. -0.67 volt we said. Sir. Then we'll see basic medium, we'll see. In basic medium, we'll see. This -1 oxidation number becomes 0 oxidation number. It is this we will consider in basic medium, we'll consider. Now we have to balance this. Here 2 oxygens, here also 2 oxygens. Here 2 hydrogens, here 2 hydrogens deficient, therefore that many water molecules. That many OH minus ions this side. That many OH minus ions this side. Now we will see oxygen and hydrogen balanced or not. We'll see here 2 oxygens, totally 4 oxygens, here 2, 4 oxygens. Oxygens is balanced. Hydrogens will see here 2, here also 2, totally 4, here also 4. Hydrogens also balanced. Next we will balance charge. Here -2, therefore we will write 2 electrons here. So we have written 2 electrons here. So this side -2, this side also -2. So charge is balanced. Next we will see the potential for this. For this potential is how much in the sense minus 0.477 volt. Minus 0.477 volt. Okay. Now first we will take oxidizing nature, acidic medium will take, that E naught will take. Oxidizing nature, acidic medium, that E naught we will compare with reductant acidic medium. So reductant acidic medium E naught C, oxidant acidic medium E naught C, which is having high oxidant. Then oxidant acidic medium we will compare to reductant basic medium, which is having high. Oxidant acidic medium is having higher value. Therefore, hydrogen peroxide is acting as better oxidizing agent in acidic medium than reducing agent. Okay. Next we will see basic medium. We'll see oxidant basic medium E naught compare with reductant acidic medium E naught, which is having high. Oxidant E naught is high in basic medium. Oxidant E naught in basic medium, let us compare with reductant E naught in basic medium, which is having higher value C. Oxidant basic medium E naught value is higher than reductant E naught value. Therefore, we can say hydrogen peroxide is a powerful oxidizing agent and a poor reducing agent, we can say. So we are concluding hydrogen peroxide is a powerful oxidizing agent and a poor reducing agent. Okay. Sorry. So hydrogen peroxide is acting as oxidizing agent as well as a reducing agent. In these two, which is better in the sense oxidizing nature is better when compared to reducing nature. So, next, how to test the given solution is hydrogen peroxide. How to test the given solution is hydrogen peroxide solution, that we will see. For salt analysis, how we are testing cation, anion, how we are testing like this. How to test hydrogen peroxide? Given solution contains hydrogen peroxide or not? How to test? That we will see. Now, we will take a hydrogen peroxide solution. We are taking hydrogen peroxide solution. To this, we will add starch iodide solution. What we are adding means starch iodide solution we are adding. How to prepare this? How to prepare starch iodide solution? First, how to prepare starch solution, that we will take. Starch solution, how to prepare in the sense we are taking rice. To this we are adding water. We are boiling this. We are boiling this to the extent such that the resultant solution will be fully white in color. This water should become completely white, dark white. Okay, then filter it. The filtrate is called a starch solution. The filtrate is called a starch solution. Okay. Now we know how to prepare starch solution. Okay. Next, to the starch solution, add potassium iodide crystals. Potassium iodide crystals, you add it. Potassium iodide contains K plus ions and I minus ions. Add potassium iodide crystals into starch solution. You will get a starch iodide solution. You will get. Now, this iodide is I minus. Hydrogen peroxide and iodide becomes what in the sense? Iodide becomes I2. iodide becomes I2. That means iodine undergoes oxidation. So hydrogen peroxide undergoes a reduction. Reduction means this -1 becomes -2. Therefore, we'll write 2 times OH minus. So I minus is converting into I2. That time hydrogen peroxide becomes 2 times OH minus. Okay, this remember it. When I minus becomes I2, this hydrogen peroxide becomes 2 times OH minus. This is possible even in acidic medium also it is possible. Okay. Then in this solution starch is there. How starch will be there means it is polymer. Starch is a polymer. So this polymeric chain, how it will be there means it will be like a coil. This polymeric chain will be like a coil. This starch is a colorless. This iodide also colorless. Hydrogen peroxide also colorless. Iodine is having color. Okay. This iodine is having color. Now this starch is a polymer we said. How this polymer will be there means it will be like a coil, winding coil. This polymer is like a winding coil. Like this coil will be there. This is starch. Inside this coil, empty space will be there. That empty space will be occupied by this iodine molecules. Iodine molecules occupying the empty space. Like this. It is called a starch iodine complex. It is called a starch iodine complex, we can say. This exhibits what color in the sense blue or blue black. What is the color of iodine crystals? Iodine crystals have violet color or purple color. Iodine crystals violet color we can say. When it goes into the empty space of starch coil, starch polymer, then we are getting starch iodine complex. This complex exhibit color blue or blue black. Okay, so we are taking hydrogen peroxide solution which is colorless, starch iodide solution colorless. We will add hydrogen peroxide solution into starch iodide solution. We will get what color in the sense blue or blue black we will get. If we get zones of color, then we can say this solution contains hydrogen peroxide, we can say. This is the test for hydrogen peroxide. Okay. Let us go for next test. Next test we will do. Now we are taking test tube. This test tube is made up of glass. It is colorless. To this we will take potassium dichromate crystals. Potassium dichromate crystals. Potassium dichromate crystals is it is solid. It is orange color. To this let us add water. It will dissolve completely. So we prepared orange colored solution, potassium dichromate solution we prepared. Then we will add acid, dilute sulfuric acid we will add, that is colorless. Dilute sulfuric acid is colorless. Then we will take hydrogen peroxide solution. That hydrogen peroxide solution we have to add in order to test. Before adding hydrogen peroxide solution, we will do one thing. What in the sense, we will take ether. Ether is the organic compound. How we are saying alcohol, carboxylic acid, aldehyde, like this ether also one functional group. That ether one compound will take, ether compound will take, that is liquid ether will take, that we will add here. We will add ether into this. Okay, we added ether into this. Then what will happen in the sense? Here in the test tube, two layers will be there now. What are the two layers in the sense? One is aqueous solution. This is what in the sense aqueous solution. This aqueous solution is orange. Why means potassium dichromate is present. Then another solution is what means above this aqueous solution, ethereal solution will be there. That means ether will be there. Ether density is lesser than aqueous solution. Therefore, ether is floating over this aqueous solution. Now this ether is colorless. Okay. So ether is floating over aqueous solution. Between these two, we can see the boundary we can see. Ether is separate layer when compared to aqueous solution. They are not mingling with each other. They are not miscible with each other. Then add hydrogen peroxide solution. Add hydrogen peroxide aqueous solution. Add hydrogen peroxide aqueous solution into the test tube. Shake the contents and leave it. Shake the contents and leave it. So what will be there? Now, two layers will be there now. Below one, aqueous solution. Below one, what means aqueous solution, which is colorless. Below one is aqueous solution, which is colorless. Above one is ether solution. Above layer is ether solution. This above one is ethereal solution. Why ethereal solution? Means ether is present, therefore ethereal solution. This ethereal solution is now blue color. This ethereal solution color is blue. Why? What happened? What is the reaction takes place here? That we will see. Now we have taken a potassium dichromate initially. That potassium dichromate on dissolving in water, we are getting cation K plus and anion Cr2O7 2 minus. Dichromate ion we are getting. So, then we added acid that gives H plus. Then we added hydrogen peroxide, that is H2O2. Now what is obtained means chromium peroxide is obtained. This chromium peroxide is highly soluble in ether than water, than in aqueous solution. This is called chromium peroxide. This chromium peroxide is highly soluble in ether than water. Therefore, this chromium peroxide goes into this ethereal solution. So this ethereal solution gets the color of blue, which is exhibited by chromium peroxide. So chromium peroxide has gone to this ethereal solution. So ethereal solution exhibit blue color now. Okay. Now why CrO5 goes to ethereal solution instead of water means the CrO5 is highly soluble in ether than water. So that ethereal solution exhibit blue color. Sir, now let us balance this equation. Before balancing this equation, let us see the structure of CrO5 and oxidation number of CrO5. Cr oxygen will see. Okay, now we have taken CrO5, we have taken. In this, let us find chromium oxidation number. Chromium oxidation number we will find, for which oxygen oxidation number we will substitute as -2, net charge we will take 0. Now chromium oxidation number we are getting +10. Now whether it is correct or wrong we will check. We will take chromium atom. Chromium atom atomic number is 24. Its electronic configuration is argon 3d5 4s1. Anomalous electronic configuration. So chromium can exhibit maximum what oxidation number means the valence shell says that it contains 6 electrons. Therefore it can show maximum +6. Therefore +10 oxidation number is not possible. So in +6 oxidation number, what is the electronic configuration means argon, inert gas configuration it has got. It can't go for still more increase in oxidation number. So chromium maximum oxidation number is +6. It's a group number if you see 6b. So chromium can exhibit maximum +6 oxidation number. That means here we are getting +10. That indicates that we have done mistake here. What is a mistake means we have considered all the oxygens as oxide. This indicates that this reveals that all the oxygens are not oxide, some are peroxides. So we want to find how many oxygens are peroxides and how many oxygens are oxides, for which take the oxidation number of chromium as its maximum value. Its maximum value is how much in the sense +6. So take that +6 oxidation number. Then sum of the oxygens carrying -1 oxidation state and sum of the oxygens carrying -2 oxidation state. Net charge is 0. Here oxygens are there. All the oxygens are not carrying -2, that we came to know. So some oxygens will take -1 and some oxygens will take -2. Like that we have considered. -1 means the oxygen present in peroxide. -2 means oxygen present in oxide. We will find now X. We are getting X as 4. That means 4 oxygens carrying -1. 1 oxygen carrying -2. Like that we came to know. So now we will write CrO5. CrO5 contains 5 oxygens totally. Now for 4 oxygens you give -1 oxidation number. Okay. For this -1, -1, -1 we have given. For 1 oxygen you give -2. Okay. -1 oxygen, -1 in the sense that is peroxide. Peroxide formula is what means O2 2 minus. It is peroxide ion. One peroxide ion formula O2 2 minus. O2 2 minus how to give means O single bond O we can give. And for each oxygen you have to give -1. This is called peroxide ion. This linkage is called a peroxy linkage. So peroxide ion means O2 2 minus, that we have to give as O single bond O we have to give. For each oxygen we have to say -1 oxidation number. Sir, that means this oxygen carrying -1 oxidation state, therefore it is peroxide. So this is peroxy linkage. It is one peroxide ion. Similarly, it is one peroxy linkage. It is one peroxide ion. This is carrying -2. -2 means that is oxide. That is oxide. Okay. Then we'll go for bonding. We'll go for bonding now. This is -2, therefore it is making double bond with chromium. It is -1, therefore it will make single bond. It is making single bond with chromium. Like this we are giving. This is just like a flying butterfly, therefore we will say butterfly structure. This contains peroxide, therefore this name is chromium peroxide. Chromium peroxide. Chromium peroxide we can say. Okay. Now let us balance this one. Okay. Here chromium oxidation number is +6. Here also chromium oxidation number is +6. No change in oxidation number of chromium. So here chromium 2 times. Here so we will write 2 times chromium. Here how many peroxy linkage is there? In one CrO5 2 peroxy linkages are there. In 2 CrO5 4 peroxy linkages will be there. Therefore 4 times hydrogen peroxide we will take. Then here oxygen will see 2 5s are 10 oxygens. Out of 10 oxygens, 8 oxygens from peroxide. Therefore 8 oxygens balance. Remaining 2 oxygens from air. Out of 7 oxygens, 2 oxygens present here. Remaining 5 oxygens as water molecules. So 5 water molecules. Now we will balance H plus hydrogen. Here 5 2s are 10 hydrogens. Here 8 hydrogens are there. Remaining 2 hydrogens. Now last we have to balance the charge. If charge is balanced automatically, then the balanced equation is correct. Okay, sorry, we will see the charge. Here -2. Here how much we have written? 2 only we have written, isn't it? Here we have tried 2. Hydrogen C 4 2s are 8, 2, 10 hydrogens. Here also 10 hydrogens. Okay. Now we will see the charge. Here -2, here +2. So net charge is 0. Here also net charge is 0. Therefore equation is balanced. Okay, sir. Now here what we have done in the sense, in this test we have taken aqueous solution of potassium dichromate, then we have added dilute sulfuric acid, then we added ether, then we added hydrogen peroxide solution. We have shaken the contents very well, then reaction took place. Potassium dichromate becomes CrO5. That CrO5 went to ethereal solution. Therefore ethereal solution exhibiting blue color, aqueous solution exhibiting colorless. It is a test for hydrogen peroxide. Okay. If we do not add ether, what will happen? If we do not add ether, what will happen? That we'll see. Okay. Now we will take what in the sense potassium dichromate we are taking, K2Cr2O7 aqueous solution we are taking. To this we are adding dilute sulfuric acid. Dilute sulfuric acid we are adding. We are adding hydrogen peroxide solution directly. We are not adding ether. We added hydrogen peroxide solution directly. We have not added ether. So what will happen here? that we will see. So in the test tube, what and all we have taken in the sense, first we have taken potassium dichromate, that is what color in the sense orange color. Dilute sulfuric acid we added, that is colorless. Hydrogen peroxide solution we added, that is colorless. Okay. So this entire solution will appear what color in the sense blue color now. Why the entire solution is appearing blue color? Because we got a CrO5. We got CrO5, that's why entire solution is appearing blue color. Sir, okay. So we got a blue color. Why? Because CrO5 is formed, that is giving a blue color to the solution. That's what we said. Okay. Then as soon as blue color is formed, immediately in the entire solution, bubbles start to come. Bubbles starts to come. Brisk effervescence will say no, not brisk effervescence. Bubbles start to come from the entire solution. Suppose if you open the cool drinks bottle, how carbon dioxide bubbles coming from the entire solution. Like that, in this entire solution, from this entire solution, bubbles start to come. Then this blue color intensity goes on reducing. Green color intensity goes on rising. Green color intensity goes on rising. Why is it so? Because CrO5 is unstable in aqueous solution. It is stable in ether, ethereal solution, organic solvent. CrO5 is unstable in aqueous solution. Why it is unstable? Because peroxide is present. Peroxide is unstable in aqueous solution. Peroxide is unstable in aqueous solution. Therefore, the CrO5 is unstable in this aqueous solution. So unstable, therefore CrO5 is converting into what in the sense Cr3 plus. Here Cr oxidation number is plus 6 is converting into plus 3. That means reduction, gain of electrons. Gain of electrons. Therefore, okay. So CrO5 is converting into Cr plus 3. Then we are getting bubbles from the solution. That bubbles is what means oxygen gas. So which is converting into oxygen gas from CrO5. From CrO5, which is converting into oxygen gas. That -2 oxygen or -1 oxygen. Which is unstable. -1 is unstable. Therefore, this -1 is converting into 0 oxidation number. Therefore, this is called what in the sense oxidation. This is called loss of electrons. Loss of electrons in the sense 1 electron. Here 4 oxygens are there. Therefore, 1 into 4, 4 electrons. Okay. So we said loss of electrons we said and gain of electrons we said. Now we have to make loss and gain equal. So what shall we do? Okay. What if we do? Then we can say loss of electrons and gain of electrons equal. Set. So we will do one thing. Here gain of electrons 3 we said, loss of electrons 4 we said. How to make gain of electrons and loss of electrons equal? Then only we can balance the equation. If you multiply with whatever the number, gain and loss will not become equal. Therefore, we can consider one of the oxygen is converting into -2. Like this we will consider. That means here gain of electron 1 electron. So gain of electron totally how much in the sense 4. Loss of electrons totally how much in the sense loss of electrons totally 3. 3 oxygens 1, 2, 3 is losing the electron. Therefore, loss of electrons 3 we will take. That means we will make this as 3. So we will make this is as 3. Loss of electrons 3 we will take. Gain of electrons 4 we will take. Now, for one CrO5 like this. Now we will take how many CrO5 in the sense we will take 4 times CrO5 we will take. We will take 4 times CrO5. Okay. 4 times CrO5 will take. Then what is the gain of electrons? We'll see. 4 times if you take, that means sorry, we will take a CrO5 4 times. 4 times we'll take. This will become how much in the sense 4 times if we take, it is becoming 12 because 4 times we are taken. This also must be 12. This also must be 12. Okay. This also must be 12. So what shall we do? This is 12 we said. This we are saying 12. Therefore, this also must be 12. So what if we do? Then it will become 12. Now, here, so if we take 4 times CrO5, then this is becoming how much we will see, and this is becoming how much we will see. So now we will see that sorry, we will do in a trial and error method. Trial and error method we will see. So first 1 CrO5 will take. In 1 CrO5, chromium is converting into +6. Chromium is for chromium gain of electrons 3. This one oxygen gaining 1 electron, therefore becoming like this. These 3 oxygens losing electrons, therefore loss is equal to how much in the sense 3. That means 3 oxygens becoming 3 oxygen atoms. 3 oxygen atoms. Okay. Next CrO5 will take. Now we are it is loss is 3, gain is totally 4. We will take next CrO5. Next CrO5 will take here. This chromium is becoming +3. Chromium is gaining 3 electrons. Chromium is gaining 3 electrons. All the 4 oxygens, all the -1, this -1 oxygens converting into 0 oxygen. 0 oxidation number, all the 4. Therefore, loss is equal to how much means 4. Loss of electrons 4. Here see, gain of electrons 4, loss of electrons 3. Here, gain of electrons 3, loss of electrons 4. Okay. Then we can say 2 times CrO5 take. Okay. 2 times CrO5. So in 2 times CrO5, this 2 times chromium becoming 2 times Cr3 plus. Out of 8 oxygens, that means -1 oxygens, out of 8 -1 oxygens, 7 -1 oxygens becoming oxygen atoms. Therefore, 7/2. 7/2 O2. Okay. So now you see that how much loss and how much gain. You see that we said in 1 CrO5, this chromium is gaining 3 electrons. This oxygen is gaining 1 electron. Remaining these 3 oxygens losing 3 electrons and becoming 3 oxygen atoms. In another CrO5, this chromium gaining 3 electrons. These 4 oxygen atoms losing 4 electrons and becoming 4 oxygen atoms, we said. Therefore, totally how many oxygen atoms? 7 oxygen atoms. Therefore, 7/2 oxygen molecules. Okay. Now, loss and gain equal. Sorry, we made loss and gain equal. Then, in this chromium, this oxygen becomes water. This oxygen becomes water. This oxygen also becoming water. Therefore, we'll write 3 water molecules. 3 water molecules we have written. Okay. Then we will balance, hydrogen will balance as per acidic medium. Let us balance hydrogen as per acidic medium, we will balance. Okay. Now we are going for balancing what in the sense H plus. Okay, hydrogen is 6, therefore 6H plus. Now we will balance electrons. Now we will balance the charge, we will balance here plus 6, here also plus 6. Okay, everything is balanced. Now here 2 is there. Now we will cancel this 2. We will by multiplying whole equation by 2. So that we will get 4 times CrO5, 12 times H plus, 4 times Cr3 plus, 7 times O2, 6 times water. So entire equation is balanced. Okay, sir. Now we will see this test. We are taking potassium dichromate. Potassium dichromate first. We are adding water. We are adding dilute sulfuric acid. Then we are adding hydrogen peroxide solution. We are not adding ether. Now the entire solution is appearing blue color. Why? Because CrO5 is formed. As soon as blue color is formed from the solution, bubbles start to come. That bubbles are called oxygen gas, and the blue color intensity goes on reducing, green color intensity goes on rising. At one stage the complete solution becomes green due to formation of Cr3 plus. CrO5 is completely converted into Cr3 plus and oxygen gas because CrO5 is unstable in aqueous solution. Sorry, okay. Now we came to know how the test for hydrogen peroxide here. Okay, so how to test hydrogen peroxide, in the sense in this manner we can test hydrogen peroxide. Okay, next test for hydrogen peroxide we will see. Next test is we will take a titanium dioxide. We will take. We are taking what, in the sense titanium dioxide. Titanium dioxide we are taking. Okay. To this titanium dioxide, let us add dilute sulfuric acid solution. Dilute sulfuric acid solution we will add. It becomes what, in the sense titanium sulfate. Titanium sulfate. Why it is becoming titanium sulfate, in the sense titanium dioxide with water becoming titanium hydroxide, titanium hydroxide with the sulfuric acid becoming titanium sulfate. So titanium sulfate we got. To this titanium sulfate, that means you are taking this titanium sulfate, that means Ti plus 4 solution we are taking. To this we are adding what, in the sense hydrogen peroxide solution. We are adding hydrogen peroxide solution. What we are getting now? We are getting a pertitanic acid, that is H2TiO4. This is called a pertitanic acid. This is called pertitanic acid. This color is what, in the sense orange. We are getting pertitanic acid. This color is orange. Sir, why we are getting pertitanic acid? Why we are saying the word per? Per word we are saying in the sense peroxide linkage may be present. Therefore, we are saying per. So whether here peroxide is present or not, let us test. Sir, for which let us find oxidation number. Now hydrogen is 2 times here, therefore 2 times plus 1. Titanium oxidation number, let us find 4 oxygens are there. For all the 4 oxygens, we will give minus 2. Then we will find the titanium oxidation number. How much it comes means plus 6. We are getting titanium oxidation number as plus 6. Is it correct or wrong? Let us check. Titanium atomic number is 22. Atomic number 22 means electronic configuration is argon 3d2 4s2. So titanium can show maximum oxidation number how much? The valency shell says that it has 4 electrons. 4 electrons means it can show maximum plus 4 oxidation state. And also its group number is 4b. Therefore, titanium can show maximum plus 4 oxidation state, but it comes here more, that because we have considered all the oxygens are oxide. That is wrong. That means it indicates that some of the oxygens are peroxide. Sum of the oxygens peroxide means how many oxygens carrying minus 1 oxidation state. How to find? For that case, make this oxidation number as a maximum possible oxidation number plus 4. That means you have reduced to 2. Therefore, you reduce to 2 here. So minus 1, minus 1. This minus 1, minus 1 means 2 oxygens carrying minus 1. Remaining 2 oxygens carrying minus 2. That's all. Then you see you will get titanium plus 4. Yes or no? You take 2 oxygens. For 2 oxygens, you give minus 1 oxidation number. Remaining 2 oxygens, you give minus 2 oxidation number. You will get titanium plus 4. Correct or wrong? Sorry. So this indicates that for 2 oxygens, we have to give minus 1. Remaining 2 oxygens, we have to give minus 2. Sorry. Okay, we will give and see. For 2 hydrogens we have given +1. Titanium we have to calculate. For 2 oxygens we are giving -1. Remaining 2 oxygens will give -2 equal to 0. Now what is the oxidation number of titanium? +4. That means for 2 oxygens we are giving -1 means here one peroxy linkage is present. Sir, so here one peroxy linkage is present, that we came to know that peroxy linkage we have written, and one hydrogen we are giving to peroxy linkage only. Another hydrogen we are giving OH. Another hydrogen OH we have given. Remaining how many oxygens? One more oxygen is there, that you give double bond O. Titanium group number is 4b, therefore its valence shell contains 4 electrons, so it can make 4 bonds. Now 4 bonds are there. It is called pertitanic acid. It is having what color? Means orange color is there. Okay, so orange color is there for this pertitanic acid, we can see. Next, we will balance this equation here. Here one peroxide linkage, therefore take hydrogen peroxide one time. So remaining 2 oxygens, how to balance? By keeping water molecules. For remaining 2 oxygens, you keep water molecules, you keep. Then we have to balance hydrogen. Here 2 hydrogens, here also 2 hydrogens, remaining 4 hydrogens, therefore 4H plus. Now we will see the charge. Charge is balanced or not. You see here +4, here also +4. Charge is balanced, therefore equation is balanced, we can say. This is the test for, these are the methods for testing hydrogen peroxide, we can say. So methods for testing hydrogen peroxide is so and so. Okay, let us continue in next class.